Today we're going to look at the three different ways that we can solve systems of equations. Let's take a look at our first example here. And what we have is 3x plus 5y equals 7 and negative 3x minus 2y equals negative 1. This first case we're going to solve by graphing. Now I want you to keep something in mind. When you just look at the first equation here, suppose we just had that right there. A solution to that equation is any x and y value that makes the left side equal to 7. So the x and y are pretty much any point that is on that line. Any point on that line will make this a true statement. Same thing with the second equation right here. I want to find an x and y that will make this equal to negative 1. So if I were to graph the second equation, any point on that second equation is going to be equal to negative 1 when I substitute that point in. And so there's an infinite amount of solutions for the first question, or the first equation, and an infinite amount for the second equation right here. What we want is a point that works for both of them. That's the key idea when we're looking at systems of equations. What x and y value will work for both of these. And so by solving it for graphing, what we're looking for is a point that is on both lines. And so I'm looking for the intersection of those two lines. Now we can solve or graph this a couple of different ways. One, and I think the way that most of my students are comfortable with doing it, is to get this thing to look like y equals mx plus b. So if I subtract 3x from both sides and divide by 5, I'm going to end up with y is equal to negative 3/5 x plus 7 over 5. And you can graph it from there if you want to. This is actually in what we call standard form already, and you can graph something in standard form. What you're going to want to do, though, is just get your x and y intercept. So if I just let x equal 0 and get y by itself, I get my y-intercept. So if x is 0, you can just cover that up because 3 times 0 is 0. And then solve for y here. Y equals 7/5. That is my y-intercept. Or you could say 1 2/5. So 1 2/5 is about right there. Then to get x by itself, I put 0 in for y. So I'm going to cover up the y and solve for x. I get 7/3. Or that's the same thing about as 2 1/3. And then connecting those points right there, I will have my line. So right there in that faded turquoise is your first line. Now I'm going to graph the second one. I'll use a different color, maybe to come out a little bit better. And you could put this in y equals mx plus b format again. And to solve for y, I'm going to add 3x to both sides. And then I'm going to divide by negative 2. So this gives me negative 3/2 x plus a third. No, not plus a third, plus a half. There we go. And so you could solve it for that and graph it that way. I think, once again, it's easier in this case just to say, all right, let x equal 0, solve for y. I get positive 1/2. So it's crossing my y-axis there. Let y equal 0, solve for x, I get 1/3. So it's crossing the x-axis about right there when y equals 0. And then we're going to graph our line like this right here. Now where they intersect is a point that will work for both lines. And they're intersecting right here at negative 1, positive 2. Now this is not the best one to solve for graphing because of those weird intercepts. If we look over at Desmos, I've graphed it there. And we can see that they are intersecting right here at negative 1, positive 2. And so that's a little bit more accurate, but it's pretty close to what we graphed here. All right, so sometimes it's easier to solve these equations by graphing. Sometimes it's easier to use substitution or elimination. This is a case where I would suggest, I probably wouldn't give you one like this on a test where you have to solve by graphing unless it was something a little bit more accurate to graph, but we're still able to come up with the answer based on what we had there. Now if we look back here, this one, same problem, but now we're going to solve by substitution. So the way we want to do substitution is to actually solve for one of the variables, pick one equation, solve for a variable, and then substitute that answer back in to the second equation that we didn't use. And so that's what we're going to do on this. We say, okay, pick a variable in software. Everybody loves solving for x, so I'm going to solve for x, and I'm just going to use the second equation there because it's easier to write on as it is right now. So to solve for x, I'm going to add 2y to both sides. I get negative 3x is equal to 2y minus 1. And then divide everything by negative 3. I'm going to get x is equal to negative 2/3 y plus 1/3. And so this is what x is equal to. I use the second equation. I'm going to take and substitute this back into the first equation for x right there. And so what I end up getting is, let's go ahead and substitute that in, negative 2/3 y plus 1/3. And the original equation, that's going in for x right here. So I'm going to just highlight that in green right there. That's where it went in. And so I still got 3 times x plus 5y equals 7. And I know some of you already are going like, ooh, fractions. And so maybe you don't like doing substitution. Substitution won't always give you fractions. Just so happens that it is in this case. The nice thing is, because of that 3 right there, the 3's are going to cancel out. It's going to make this fractional stuff go away when I distribute that negative 3, or no, that positive 3. So this gives me negative 2y plus 1. That's multiplying everything in there by 3. Plus 5y equals 7. Let's get those like terms together. I've got negative 2y and positive 5y. That gives me positive 3y plus 1 equals 7. 3y equals 6 when I subtract 1 from both sides. And then y is equal to 2. So that gives me my y value. Don't forget we need to get an x value as well here. And so I'm going to put that 2 back in and solve for x. It doesn't matter which equation I choose. I'm just going to choose the first one because everything's positive. And we like to be positive people, right? 3x plus 5y equals 7. Y equals 2. And so I'm going to put 2 in here for y, and I get 3x plus 10 equals 7. Subtract 10 from both sides, and I get negative 3 is equal to 3x, and x equals negative 1. So much for being positive, right? So x equals negative 1, y equals 2, but we already knew that because we solved it by graphing just a second ago, right? Where we saw it cross at negative 1, comma 2. So that's our second way we can do it, substitution. Once again, this would probably not be my preferred method. Once I get to this and start to see it's going to be some nasty fractions, I might say maybe there's a better way. Maybe I should try graphing, or maybe I should try the one way we haven't discussed yet, and that is elimination. So let's do the same thing. Let's solve this same problem, but this time we're going to use elimination. So elimination works like this. We're going to make sure that, well, we're just going to choose a variable to eliminate and make sure that their coefficients are the same number but opposite signs, okay? In this case, they're already the same number and opposite signs if we choose to eliminate the 3's. Not the 3's, the x's. So notice 3 plus negative 3 is 0. So once you have them set up so that they are opposite signs and the same number, which this one already lends itself to, we can add up the 2 equations and eliminate one of the variables. So all I'm going to do is just draw this addition bar here. That's that faded marker. Let's get rid of that thing. Draw an addition bar there and add these up. So 3 plus negative 3 is 0. So those cancel out. This one's faded too. Time to make a trip to the store, huh? Here's a different one. I think this one's working. 5 plus negative 2 is 3, so I get 3y is equal to 7 plus a negative 1, which is 6. Divide both sides by 3, and I get y is equal to 2. Wow, that was so much easier, wasn't it? But that just gives me y equals 2. We still need to go back in and show the steps to get the x value. So once again, I'm going to do this. We just did it a second ago, but let's do it again. Put 2 in for y up here. I get 3 times x plus 5 times 2 equals 7. 3 times x plus 10 equals 7. 3x equals negative 3, or x is equal to negative 1. So I get negative 1 here, y equals 2 there, and we write it as an ordered pair, negative 1, comma 2. That's where the 2 cross. We saw it with graphing, we saw it with elimination, and we also saw it with substitution a second ago. Now, you're probably thinking, wow, elimination's so much easier. That's the one I'm going to pick every time. But it just so happened to be easier on this problem. There are some problems where it's easier to graph them, some problems where it's easier to do substitution, and then some like this one where you're better off just doing elimination. With experience, you'll learn to pick, which one you want to pick to solve the problem. I want to give you this one right here. Another example, not just the one we've done 3 times over. Try this one out and try using elimination this time. Now you may be thinking to yourself, wait a minute, this one doesn't already have it set up for me. The last one we had 3x and negative 3x, you could just add them and they canceled out. So for something like this, we want to set it up so that it does look like that. We want that leading coefficient to be the same and then opposite values. And so if I can get by with just multiplying one equation by a number to make it look like that one, I will. In this case, though, I can't do that because 5 is not a multiple of 2. So you can eliminate the x's, which is what I'm going to do, or you can choose to eliminate the y's, whichever one you want to do. But you want to pick one and then find the least common multiple of their coefficients. So a number that 5 and 2 will both go into. In this case, it's 10. So I want to make that top one look like 10x. And to get there, I'm going to multiply the top by the number 2. I can't just multiply the 5x by 2 because that changes the equation. But if I multiply everything in the equation by 2, then that will algebraically be okay. So this becomes 10x plus 6y equals 18. For the second equation, I want to make that look like negative 10x. To do that, I'm going to multiply the second equation by negative 5. Every term in here gets multiplied by negative 5. 5 times 4 is 20, and this is going to be a positive 20. And then 5 times, or negative 5 times 14 is going to give me negative 70. Now I've got them so that they are the same number but opposite signs. I can add the two equations up. The x's get eliminated because it becomes 0x. This becomes 26y. And then this right here is going to become negative 52 when you add 18 and negative 70. Dividing both by 26, I'm going to get y is equal to negative 2. Now, we don't want just the y value. We also want the x value. So now that I know y's value, I can pick whichever equation I want, substitute that y value in, and then solve for x. So I'm going to substitute it into the bottom equation here. So it's going to become 2 times x minus 4 times negative 2 equals 14. I just substituted that negative 2 in for y. And then this becomes positive 8. And subtracting 8 from both sides, I get 6 is equal to 2 times x, or x equals 3. So writing this out as an ordered pair, I get negative 2 comma 3. That is where the two cross each other when you graph them. So that's the only point that will work for both equations and make them true statements. All right, let's take another look at another one. This time I'm going to let you pick whatever method you want to. So look at this right here and give it a try. I want you to solve using any method. All right, taking a look at it, I'm going to choose elimination just because it's super fast. When I see this leading coefficient of 1, I think, you know what, if I can just make it a 2 right there, then adding these two up will eliminate the x's. But I can't just put a 2 right there. I've got to multiply everything by 2. So I'm just going to write it below right here. I get 2x minus 4y is equal to 6. And then I'm ready to add up the two equations. So this is equation 1 moved down here after I multiplied it by 2. And now adding these up, these will cancel. And I get, look at that, these cancel also. So what happens when I add these up? I get 0. Because negative 2 plus 2 is 0x, which is 0. And 4 plus a negative 4 is also 0. So I get 0y there. So it's just 0 on the left side. And on the right side, adding these up, I get just 7. So I get a non-true statement here. 0 does not equal 7. And so at this point, what I normally do when doing a problem is I go back and check and say, this is weird. Let me go back and check and make sure I did all my math right. So I'd go back and double check and be like, yeah, I got 0 equals 7. And so since that's not a true statement, we're going to say that there is no solution here. Always good to double check when you get something weird. But in this case, it all checks out and you get no solution. So what does that mean, no solution? What does that look like graphically? You know, I said earlier that when you graph them, where they cross is your solution. So if you're getting no solution, what does that say about where they cross? Let's take a look at Desmos and see what we get there. So we're going to switch here to Desmos. That's what I had up earlier. Let's put in these graphs. And so we get x minus 2y is equal to 3. And you could solve this by graphing and graph these out and get the same thing that we just got here, no solution. Negative 2x plus 4y is equal to 1. So look, where do they cross here? They don't cross anywhere, do they? So since they don't cross, they're parallel lines. In fact, if we were trying to graph these and we put them in y equals mx plus b, we would see that they have the same slope but different y-intercepts, which means they're parallel lines. They never cross, and so there's never a point that works for both of them. So there's no solution. All right, let's take a look at another one. So in this one, I want you to use any method again and solve for the system. Once again, I'm going to use elimination in this case because I see that 2 and 4 are so close to being multiples of one another. And so I'm going to take this top equation, I'm going to multiply it by a negative 2. And what that does is that gives me negative 4x, and that gives me positive 2y right here. And then that gives me negative 2 over here on the right side. And so you might be saying, I did it a different way. It's okay. If you solved it one of the other two ways, I don't care because it said to use any method. On the test or quiz that I give you, I will have you demonstrate at least that you know how to do one of each of these. But a lot of times I give you the option to use any method you want. So adding these up, I get 0x on the left side. Oh, once again, I get 0y on the right side. So, no, I'm sorry, 0y on the left side. So everything on the left side adds up to 0. And then on the right side, though, I also get 0. 2 plus a negative 2 is equal to 0. So I get 0 equals 0. Now that's different than last time. Last time we eliminated the variables and we got a non-true statement. This is a true statement. 0 does equal 0. So once again, something weird, and I'm going to go back and double check my work. Did that. And then I'm going to say, okay, 0 equals 0, that is a true statement, so there are infinitely many solutions. Infinitely many solutions. And that's your answer there. Not 0 equals 0, but infinitely many solutions. That means that you pick any point on this line, and it's also on that line. So what does that mean graphically speaking? Let's take a look at Desmos and see what we have here. So delete, that's what we had in the last question. Let's get rid of that stuff. And I'm going to type in what we just had. 2x minus 1 is equal to 1. Sorry, 2x minus y is equal to 1. So that's one equation. And then the other equation is 4x minus 2y equals 2. There's my other equation. Now what happened to the red line? Well, if we turn off the blue line, the red line is right there on top of it. So these two things are intersecting everywhere. That's why there's infinitely many solutions, because they cross each other. They're everywhere. They're the same line. And sometimes we don't immediately see that when we're looking at the equation right here. But if we were to put in y equals mx plus b format, we'd see that they have the same slope and the same y-intercept, which means they are intersecting everywhere. Okay? So there are two special cases that you'll see when you're doing solving systems of equations. You'll come up with no solutions. You'll come up with infinitely many solutions. Be aware that they're there. It's also 3 different ways that you can solve systems of equations that we went over today. Now, don't just stop here in this video and be like, I got it. You need to go through and do a ton of practice problems. So that way you are familiar with them and you're ready for the quiz and the test. I'm going to create another video just going over examples, okay? This was just to get you started today. So go ahead and try the assignment that I gave you, and then you can watch my video on additional practice, so that way you're prepped for the quiz and the test. Thank you for watching. Keep working hard, and I hope you're having a great day.